Good evening, everyone. Welcome to the fourth problem on the homework portal series. And today we are doing a problem on electricity. Okay, so now let us load this particular problem. Right. I hope you are all getting all the questions appropriately. You're trying it out yourselves. Okay, just a moment. Why it's not showing. Just a moment. Wait, let me see what's wrong with this. Okay, everything is fine, I think. Right. Just a moment. Okay, fine. Now it's working. Okay. Anyway. So this question is for 9 marks. So already 1 minute I have spent over here. Let me try to finish it up within 9 minutes. Right. Okay. So let us start. A capacitor is a device that can be used to store electric charges, right? An experiment was undertaken to investigate one of the circuit's properties of a capacitor. Capacitor C was connected via switch S. This is your capacitor, switch S, to a resistance R and a voltmeter V. Okay. The initial potential difference across C was 12 volt. Initial potential difference was 12 volt. Oh, there's no battery connected. Okay, fine. The switch S was closed and the potential difference V across R was measured at various times. The moment you close this one, all the charge present in it will now start migrating like this. It goes over here. So because this is a resistor, what can happen? It can lose charges. It can lose some energy, right? So therefore, the data collected along with the error bars are shown, right? And then what is this plot? V versus time taken. Okay, time taken. Now, what is the question? On the graph opposite, draw a best fit line for the data starting from t equal to 0. Okay. So we need to draw a best fit line here. We start from here, then draw it like this. Though it may not be exactly right, but anyway, to some extent I have drawn. Okay, as compared to yesterday's problem. So it is not like this, it's almost okay. So this line, this region is not so good. Okay, now first part is done. It was hypothesized the decay of the potential difference across the capacitor is exponential. Once again, exponential. Determine using the graph whether this hypothesis is true or not. So, what method would you go for finding out whether it's an exponential relationship or not? Okay, so that's what is the question. So, towards it, what you do is, how do you verify something is exponential or not? You will take for equal values. What is the test? If you go to my video in, I think it's in video number 5, you'll be able to see. Okay, so if you have y1 is equal to a e to the power of ax and y2 is equal to a e to the power of a x2 and x1, such that x1 is equal to x2 plus h. Okay, when you have something like this. Okay, and let us say one more, y3 is equal to a e to the power of ax3 and x2 and x3, I'm sorry, x2 is equal to x1 plus h, x3 is equal to x2 plus h, which means what? It's an equal differences. Then y2 by y1 should be equal to y3 by y2. Okay, this ratio should be equal to this ratio. Okay, so when you find something like this, definitely it is exponential. This is one way of putting it across the exponential relationship. The other way of putting it across, it's a very crude way, is that we know that this relationship is also seen to be true in case of radioactive decay. Okay, so what happens in radioactive decay? N equal to n naught e to the power of minus lambda t is nothing but your exponential way, which is very similar to this. And then what happens? You have n0 initially, okay, like shown here. Then after one half-life, this becomes n0 by 2. The other half-life, it becomes n0 by 4, and it continues like this. Okay, you can try it out with this also here. What we'll do is let us try for this one here, for this point. Let me consider this value is equal to n0. What is this value? Easiest way. If I want to do it faster, I can do like this. If this is 5, this is 7.5, this should be 8 here. Okay. And this is at a time 5 here. Okay. Now, if 8 has to become 4, then it will take 1.5 life, right? Apply the same thing. So if you are aware of the domain knowledge, you can go by this. If you are aware of the mathematical knowledge, you can go by this way. Okay. So therefore, if this is 8, it becomes 4. Where does it become 4? It's 2.5. This becomes 4 here. This becomes 4 at this point over here, which becomes a 10 over here. Okay. So this is your time taken t. So 8 becomes 4 at a time of 5 seconds. 5 seconds. Okay. Now we need to test it for one more interval also. Now 4 becomes 2. Where does 4 becomes 2? This is your 4 here. 2 will be somewhere over here. Now when you take this line parallel to this, it will intersect the curve here, and you see it is at this point. So 4 becomes 2 in another time period t. Another time period t, 5 seconds. So when you are able to prove that it is same for two of them, then definitely this is undergoing an equation very similar to it. In other words, it is an exponential decay. Now what is the question here? It is hypothesized that decay of the potential difference is exponential. Okay. Now it is for 4 marks. How do you write? Now first one is, you can say radioactive decay. Radioactive decay also follows exponential relationship. Exponential relationship given by n is equal to n naught e to the power of minus lambda t. And this is your first 1 mark you get. And what is that you get? N naught at t equal to 0. T equal to 0. After a time, capital T becomes n naught by 2. And after another time, it becomes n naught by 4. And after another time, it becomes n naught by 8, and so on. Okay. Now comparing this. Now you already get 1 mark here. These are 4 marks. You get 1 more mark here because you stated the condition also here. Now what you do? Or this will be including this. Comparing N0 with V. We have V becoming V0 by 2, becoming V0 by 4, and so on. Okay. And we need to prove that capital T is same for all decreases. So what did you do? You took the value of V. Now you need to show that. Okay. Further, this is for 1 more mark. 1 more mark. Okay. Now you need to take up that value. Which value? The value that you have shown over here. Right. It is observed that, for example, at t is equal to 5 seconds, you need to write here. At t equal to 5 seconds, V was 8 volt. At t is equal to 10 seconds, V was 4 volt. At t is equal to 15 seconds, V was how much? 5 volt. 5 volt. Okay. Thus periodically for every time it keeps on decreasing, and as a result of it, this is an exponential relationship. You can prove it like this. Then second one. The time constant tau of the circuit is defined as the time it would take for the capacitor to discharge, where it to be discharging as its initial rate. So he says you need to discharge it. Okay, fine. Use the graph in A to calculate the initial rate of decay of potential difference. Whenever there is a rate coming here, which means delta V will be decay of potential difference divided by rate, means it should be delta T. You need to find delta V by delta T from the graph. Where is the graph here? Graph is here. So you get a graph of V versus T. Starts from here, right? Starts from here. You get a graph of V versus T. Delta V by delta T, how do you get? Draw a line. Draw a line here. Draw a line here. Right? Draw a line like this. It cuts just like this over here. Now what is he asking? Where do you want to find initial rate? Okay. You could have drawn a line anywhere here, right? You could have drawn your tangent here, tangent here. When you say initial rate, you need to draw it only at t equal to 0. At this point, when you draw it, Now, what is he asking? He is asking you to find out delta V by delta T. So, what is delta V by delta T here? Delta V, Let me take the whole thing from here. From here, what is this value here? This is 10. This is 10 here. Then this is 5, 7.5, 10 here, right? Then this is 10. Then this should be 12.5, right? This should be 12.5. This should be 12 here. This should be 12 over here. If this is 12, this is 0. Delta V should be 12 divided by time taken. See, look at this point here. This is 5, 7.5, 10. This should be 10.1 something. 10.1, right? 10.05, 10.1, and so on, right? Because this is 12.5, 10 point, just a minute, wait, 10.5, 11, 11.5, 12, 12.5. Okay, this should be 10.5, 11 here, 11 here. 12 by 11 should be your answer. Delta V by delta T should be 12 by 11. When I do this, how much do I get? Where is it? My calculator is not seen. It's here. Okay. So I get the answer as 12 divided by 11 is 1.09. Get the answer is 1.09 volt per second is what I get. What is the correct answer? The correct answer is 1.3 volt per second. Okay, as in the marking scheme. But it has already been said that it can vary between 1 to 1.4. Okay, so therefore, so ours is almost within the threshold. Okay, maybe if you do it correctly by using a graph by scale, okay, you will get it correctly, because mine, the line is not exactly coinciding here, right? Okay, so therefore we have done this also. This should be 1.1 volt per second. Time constant tau. How do you get the value of time constant tau? What is time constant? Once again, come back to this point. Time constant tau. What is being given here? See, graphical part, you have to be very careful when you do this. You need to get the value of time constant. So what is the equation here? The equation here is V is equal to, what's the equation? V is equal to, somewhere the equation is given, right? Where is the equation given here? On the graph, let me check it out. Where is the equation given here? Equation is not given anywhere over there, right? Okay. Now, how do I find the time constant? That's what we need to look at. Okay, let me read the question first. What is time constant? The time constant type of the circuit is defined. Okay, it's already given here. It's defined as the time it would take for the capacitor to discharge, where it to keep discharging at its initial rate. If the capacitor was discharging at its initial rate, if it was discharging at the same way, then the time required to completely make the voltage to be zero. See, where does the voltage become zero? Voltage becomes zero here, right? Okay, when does it become zero? At a given time here, right? What is the time here? We estimated this as equal to 10.5, 11 seconds over here. This should be your time constant. So 11 seconds should be your time constant. Your marking scheme says this should be 9.5 seconds because of the line that we have got it incorrectly. Okay. So with this, I think we have come to an end to this particular problem. Let us see more problems in the tomorrow's video. Okay. Thank you.